KAAN, with the project name National Combat Aircraft TUSA, is a twin-engine fifth-generation jet combat aircraft that Turkey plans to bring to the mass production stage at the end of the 2020s, with superior features in low visibility, sensor fusion, air-air and air-to-ground dominance. Project. It is planned to make its first flight in 2023. It is expected that MMU will initially replace the old F-4 and F-16 aircraft in the inventory of the Turkish Air Force and then be exported to foreign countries. Initially, the MMU's design began to compensate for the weaknesses of the F-35 project, of which Turkey is also a partner, in air-to-air combat. However, the sanction process that started after Turkey bought the S-400 air defense system from Russia resulted in the official removal of Turkey, which is a manufacturer, from the F-35 program, and the MMU became Turkey's only ongoing fifth-generation fighter aircraft project. It has been officially announced that the prototype of the MMU, TFX, will be launched on March 18, 2023 and will make its maiden flight at the end of 2023. The taxiing and ground-running tests of the prototype officially began at the launch on March 17, 2023. It was officially named KAAN on May 1, 2023. Prototype of the MMU, TFX, at the Paris Air Show. In 2011, TAI started the conceptual design phase of the TFX, which is intended to have a low-visibility body design in the fifth-generation warplanes class, which will be produced with avionics and composite materials with the ability to dampen radar waves, and the conceptual design studies have been started on September 29, 2013, was completed in determining the operational needs of the Air Force's Command for Jet Trainer and Combat Aircraft Needs, analysis of requirements and meeting them, conceptual design of the aircraft and its systems, researching national possibilities and capabilities and feasibility and international cooperation models. Worked on the titles. An agreement was signed with TAI and the Swedish company Saab. Saab AB will provide technological design assistance for Turkey's TFX program. Design selection. In the evaluations made until 2015, 3 designs stood out. FX1, twin-engine, Lockheed Martin F-22-like design. FX5, single-engine, General Dynamics F-16-like design. FX6, Saab JAS-39 Gripen-like design with single engine and wing. Developed by TBITAC Sage and Roketsan, the SOMJ cruise missile is designed to fit into the interior weapon compartment of the MMU, TFX, and F-35. It was stated that the twin-engine FX1 model, which is longer than the others, can carry more weapon loads, and can reach higher speeds and range, should be preferred. 15. Bidding process. On March 13, 2015, the Turkish Undersecretariat for Defense Industries, SSM, officially issued a request for information file, RFI, to Turkish companies in order to carry out domestic design, development and production activities to meet the next aircraft procurement program of the Turkish Armed Forces. 16. In the same period, TD, Call for Proposals file, was published for the engine of the aircraft, and General Electric, Eurojet and Snecma companies returned to this file. Within the scope of TD, an engine that can develop the engine infrastructure in Turkey and that will be domestic production as long as possible was requested. Agreement with BAE Systems. In December 2015, Turkey's Undersecretariat for Defense Industries, SSM, announced that it had selected UK subsidiary BAE Systems to assist in the design of the country's next-generation air superiority fighter. On the same day, Rolls-Royce offered Turkey the technology transfer of the EJ200 engine and the joint development of a derivative for the MMU program. 17. Cooperation between TAI and Havelsan. In May 2020, TAI and Havelsan signed a cooperation on embedded training/simulation, training and maintenance simulators and engineering support to be provided in various fields, virtual test environment, project-level software development and cybersecurity. Although the Phase 1 part of the development process was aimed to be completed by the end of 2014, the situation called T0, which indicated that the initial conditions were met and the project officially started, was at the end of 2018. On June 30, 2021, the Turkish Air Force made a public presentation about the MMU program. In the presentation, it was stated that the preliminary design studies started with Phase 1, right after the T0 phase. System Requirements Review, SRR, is conducted as part of preliminary design activities. System Functionality Review, SFR, and System Requirements Review, SRR, processes are targeted to be completed by the end of 2022. Thus, the preliminary design activities will be completed. Within the scope of Phase 1 Phase 2, MMU's detailed design and qualification activities will be carried out in the 2022 to 2029 period. The aircraft will leave the hangar in 2023, Critical Design Review, CDR, activities will be carried out in 2024, the production of the first aircraft, called Block 0, will be completed in 2025 and the first flight will be performed in 2026. Until this date, it is aimed to produce 3 prototypes. The Block 1 configuration is planned to be developed until 2029. Within the scope of Phase 2, the production of 10 Block 1 fighter jets is planned, and the planes will be delivered to the Turkish Air Force between 2030 to 2033. In Phase 3, development and mass production activities of other MMU blocks are planned between 2034 and 2040. Rear view of the MMU, TFX, prototype. Le Bourget, 2019. Start of part production. On November 4, 2021, the first piece of MMU was produced. Temel Kodal, General Manager of TAI, we have realized the production of the first part of our national combat aircraft. Every step we take for the survival project of our country is very meaningful and valuable for us. I would like to thank all my friends for working on the same path with enthusiasm and effort, made statements. Allegations of cooperation with Pakistan. Pakistani retired General AVM Dr. Rizwan Riaz and TAI General Manager Professor Dr. Temel Kodal announced that the MMU project was carried out in cooperation between Turkey and Pakistan. It was stated that Pakistan's savings within the scope of the AZM project will be used jointly with Turkey's savings within the scope of MMU 23, but later, TAI sources said that this was a misunderstanding and that no such agreement was made. Final assembly line process. MMU's production of parts, which started on November 4, 2021, continued for 1 year. The parts produced were combined and the aircraft entered the final assembly line on November 23, 2022. The actual images of the prototype of the MMU were also shared with the public and press organs for the first time on this date. In December 2022, the aircraft was taken on its own wheels, its canopy and engines were installed. Testing process. On March 16, 2023, the National Combat Aircraft was removed from the hangar for tests after the completion of production. The engine-powered aircraft moved on the runway for a while and performed its first taxi test. Avionics, sensors and hardware. The MMU will integrate with its accompanying UAVs via an encrypted data link. MMU has probably a Selson Zone Radar Warning Receiver, RWR Radar Warning Receiver, Missile Warning System, MWS Missile Warning System, Laser Warning System, LWS Laser Warning System, Deceptive Particle and Sign, which were developed previously. It will be equipped with light management, distribution system and digital radio frequency memory, DRFM, digital radio frequency memory, based jamming system. These engines are currently used in F-16s. Three-dimensional titanium printer technology will be used in the production of a 7-meter-long reinforced titanium piece, which is required to integrate the engine into the aircraft. Alternatively, Rolls-Royce Company and TR Motor Power Systems SAN, Inc. continues its efforts to develop a fifth-generation turbofan engine with domestic facilities. As of June 2022, the F-110 engines to be used in prototype aircraft were delivered to Turkey. Double-seat variant. In March 2022, TAI announced that a tandem double-seat version of the MMU could also be developed. Accordingly, it is aimed to use the MUMT, manned-unmanned teaming, capability of the national combat aircraft with the highest efficiency. With the seat to be added, the pilot in the back seat will be able to coordinate and manage unmanned aerial vehicles such as Bayraktar Kızılelma. At the information meeting held in January 2023, it was stated that the double-seat variant would not be produced, and it was stated that the duties expected by the pilot sitting in the second seat would be completely transferred to the aircraft's computer. The model of the aircraft, prepared in exact dimensions, was introduced to the public for the first time at the 2019 Paris Aviation Fair, 29. In June 2021, the design features and needs of the MMU were explained in the presentation of the Turkish Air Force to the press. Frowny Face 21. High maneuverability and a powerful propulsion system. Super navigation capability. Long radius of action. Low visibility on radar. Sensor fusion. Advanced data link capabilities. Ability to fire high-precision ammunition. Aircraft fuselage. Hüseyin Yagsi stated that the MMU program has been optimized for low radar cross-section density, interior weapon bays and super navigation capability, which has been visualized in 3 conceptual designs of TAI. These are the features associated with the 5th-generation fighter aircraft. TAI's advanced carbon composite fuselage facility has been prepared to manufacture the fuselage for the Lockheed Martin F-35 Lightning II aircraft. The Turkish Undersecretariat for Defense Industries, now the Presidency of Defense Industries, has also issued a tender for the development of a new lightweight carbon composite thermoplastic for the MMU body. It is stated that the aircraft consists of 4 main parts: the front cockpit, the middle fuselage, the wings and the tail. It has been explained that 7050 and 77450 series aluminum is used in the front section, titanium is manufactured in the middle body, and the outer cover and air intake inlets are made of composite material. Radar and sensors. The AESA radar to be used in the aircraft to be produced within the scope of the MMU project will be the Integrated Radio Frequency System, BRFES, produced by Aselsan. Crew. 1. Length, 21 meters, 69 feet. Height, 6 meters, 20 feet. Wingspan, 14 meters, 46 feet. Power source, 2 times General Electric F-110 GE-129 afterburner turbofan, prototypes only. Propulsion without afterburner, 2 times 17,155 pounds force, 76 knots. Afterburner thrust, 2 times 29,400 pounds force, 131 knots. Performance. Top speed, Mach 1.8, 2,210 kilometers per hour, 1,190 knots. Service ceiling, 55,000 feet, 17,000 meters. G limit, +9 G/-3.5 G. Avionics. Aselsan's domestic AESA radar integrated RF system, BRFIS. SAR, synthetic aperture radar system. IRST, infrared search and tracking sensor, CARAT. EOTS, electro-optical targeting system, TOYGUN. DIRCM, directed infrared countermeasure system, Yildirim 300. Helmet-mounted sight system, 3 Turkey's domestic and national warplane, KAAN, does not go unnoticed with its features and capabilities. TAI General Manager Professor Dr. Temel Kodal spoke highly of the National Combat Aircraft KAAN at the Paris Air Show. Drawing attention to the striking power of KAAN, TUSA General Manager Kodal said, it shoots from 200 to 300 kilometers with its radar and missile. If Rafale comes, you can take it away. F-16 can never come close. Including Block 70, F-15, F-18, Su-35, S-out. He emphasized that KAAN is far beyond the current warplanes. Talking about KAAN, which is counting the days to fly in the skies, Temel Kodal said, after 2 years, we will fly here, Paris Air Show, and bring it here. Whatever he will do, we called him KAAN, the King of Kings used the phrases. National Combat Aircraft KAAN. The KAAN development project, which was initiated with the aim of producing a fighter aircraft designed and developed with domestic means and capabilities that can replace the F-16 aircraft, which is planned to be phased out from the inventory of our Turkish Air Force Command as of the 2030s, and to create the manpower and infrastructure to design and develop this aircraft. TAI is the main contractor in. With the capabilities to be gained in technology areas such as low visibility, internal weapon slot, high maneuverability, increased situational awareness and sensor fusion, which should be in a new generation aircraft in the project, USA, Russia, China etc. in the world. It will take its place among the limited number of countries that have the infrastructure and technology to produce a 5th-generation fighter jet. KAAN will operate in cooperation with other warplanes in the inventory of the Turkish Air Force Command, platforms such as unmanned aerial vehicles, UAV, and airborne warning and control, HIK, and other elements planned to be procured, and that the aircraft to be produced will be produced by the Turkish Air Force until the 2070s. It is envisaged to be included in the inventory of the command. The KAAN, the 5th-generation multi-role fighter aircraft, provides superior capabilities for the requirements of both air-air and air-ground combat. KAAN, the strong and agile platform of Turkish aerospace industries with high survivability, he is a true warrior with his smart and powerful combat abilities. Test activities and the most advanced engineering tools and methods are used to determine and optimize the aerodynamic geometry, which is one of the most important steps in the KAAN development project. The KAAN cockpit design is being matured in order to minimize the pilot's workload by considering the capabilities and equipment that the 5th-generation warplanes should have. In the design process, a cockpit environment is developed that will increase the pilot's situational awareness, taking into account the physical, cognitive and environmental factors that the pilot is in. KAAN superior air dominance. Increased air-to-air combat range with new weapons. Precision and precise strike from internal weapon slots at high/supersonic speed. Increased combat power with artificial intelligence and neural network support.